Good afternoon, everybody. I'm also delighted to have been invited to speak here. Although I'm very interested in agriculture and have a wide perspective, having been involved with industry and actually been a farmer myself for about 15 years, and been involved with the industry for about 40 years, I'm going to limit myself because a lot has been said about the foreground of population growth and technology. I'm going to concentrate just on one specific thing, which is complicated enough. I've been involved with it for about 16 years, so I have a little less than a minute for each year to describe what's going on here to the best of my knowledge. I need to be able to work this device. I guess I just do that. Do I have to point it at anything? Where is it? This one? Yeah, that's the pointer bit. And this one advances the slides? Yeah, okay. So this slide, Howdy's talked about biofortification. And in this slide, I've tried to illustrate some important things about vitamin A deficiency, which is the most important micronutrient deficiency in terms of mortality and childhood blindness. And the little map on the top left shows that this is essentially a problem of the developing world. And that's because it's associated with poverty. It's associated with insufficient dietary diversity, too much dependence on staple foods, which are mostly carbohydrate with very few sources of minerals or vitamins, and where the foods which contain the minerals and vitamins become too expensive. And for the vitamin A, only animals make vitamin A, so the sources of vitamin A are animal products like liver and eggs, butter, cheese, but these things are generally outside the ability of poor people to afford, and if food prices go up, the staple foods go up less than the animal products, so they become more deficient in the micronutrients, including vitamin A. The little graph on the right shows that there are two effects of decreasing vitamin A, and the y-axis on the left-hand side, the low levels are at the top of the axis, which is slightly confusing. With less provitamin A, there is a major effect on immune system. The immune system doesn't work properly anymore, so mortality goes up. And that's the main thing, and the mortality goes up as a result of common diseases which affect particularly those individuals at great physiological stress, which is our mothers and children and developing, neonates in particular. As well as that, and as a separate modality, is effect on eyesight, leading most importantly to complete loss of blindness, irreversible blindness. And these two things occur differently. Most of the people who die from lack of sufficient vitamin A do not become blind first. So vitamin A on bottom left, vitamin A-induced xerophthalmia is the leading cause of childhood blindness. And it has been shown, and Howdy Buis in front of me, referred to one dimension of saving 23% of lives. Actually, the range from meta-studies is 23 to 34% of all global under 5 mortality in children can be prevented with a universal source of vitamin A. And in the case of measles, availability of vitamin A reduces mortality by up to 50%, according to the World Health Organization. So in this little table on the lower right, vitamin A deficiency in 2014 killed between 1.4 and 2.1 children under the age of 5, more actually than the mortality from those other major public health problems. Now, because this problem has been known about for a long time, at least the last 25 years, the United Nations has been making repeated attempts to control the problem, and there are other interventions, including trying to improve dietary diversity, including provitamin A tablet capsules, but these deaths have still occurred. And to put this into a context, let me see if I can change this. What do you do with this thing? Okay, I jumped 2 slides here. I wanted to put this into a context. In 9/11, about 3,000 people died in that attack which changed the world's politics. but about 5,000 people the same day, or 5,000 people actually more in 2001, but in 2014, about 5,000 preventable child deaths occur, and that's every day. And that little plane flying towards the building has a capacity of 168 people. So that 5,000 people, children mostly, that died, is equivalent to more than one plane every hour of every day crashing into the ground, killing all the children on board. And the world doesn't take any notice. So you can understand why we need to do something about this. Especially, as you will hear, there is a potential solution that can be more effective than the current ones. Now, we congratulate Howdy for his award in the World Food Prize, and Jan Lowe and the other two people that I haven't come across before, only seen the photos. I think Jan was working on the orange flesh sweet potato to the top right before Howdy got going with Harvest Plus in 2003, and has done some work showing how you get improved retinol status, vitamin A status in children as a result of consumption of it. And I guess the rest have been involved in increasing the uptake of that crop. And you notice the orange color here very prominently in the maize crop and in sweet potato. Maybe there's other crops there I don't recognize. And that's because the provitamin A has a yellow color. It's the same color, the same chemical that's in carrots, basically. And that's what animals convert, including humans, convert to provitamin A. In this table on the top left, you'll see in the second crop up from the bottom, I think it is, I can hardly read it from here, maybe you can't either, is sweet potato. But right at the top there, in terms of millions of calories, 2 million calories a day in between 2000 and 2004 were provided by rice, and less than 2% of that by sweet potato. And rice feeds about half the world's population every day, with 80% of its 80% or plus of its calories. Most of the rice is illustrated in where it's grown. Is a lot of it in Asia, some of it in Africa. And Peter Bayer and Ingo Petraikas produced their first prototype following about 10 years' effort in 1999, which was published in this issue of Science in the year 2000. Now, how come with the very small, with all the respect to the sweet potato, the orange sweet potato, and a project that started with Harvest Plus in 2003, did this invention, which has the potential, it contains provitamin A, to feed half the world's population, not even got to a farmer and not even been planted by real farmers now in 2016? And the reason, of course, is about regulation and attitude. In 2000, this is an issue of Time, we already saw the politics coming into effect. This was the US issue of Time, US edition front cover on July 31st, 2000. The Asian edition also featured another golden rice front cover. The European edition didn't even cover the story inside, let alone on the front cover. The golden rice vision, and incidentally this is a picture of golden rice taken from the first field trial in US in 2004, was to create a public good source of provitamin A, source of vitamin A. And just to correct something that there's sometimes misunderstood, the intention is, and the donation from the inventors right from the beginning, Peter and Ingo shown here in a picture taken in 2002, was to make the nutritional trait available free of charge, to be introduced into public sector varieties of rice. Nobody can afford to give free rice to half the world's population every day, but the trait, once it's introduced into any locally adapted and preferred variety of rice, can be provided free of charge, and we work with a network of public sector institutions, rice breeding stations in the developing countries to do that. There should be no charge for the trait, coming back to the vision. It should be available to those who want to grow it or consume it, and it should be an additional intervention to add to the existing interventions to combat vitamin A deficiency. So that was the vision. The politics are already coming in 2000, in the year 2000 with this story. And incidentally, I think Peter mentioned the other day that this was Time. Nature had previously turned down this project, Nature being a European magazine, basically, and Time coming out of the US. Well, in Greenpeace in 2001 immediately started making complications for the project. I've highlighted some words from the selection from their press release issued in February 2001 here. First of all, the genetic modification industry. They first start honing in on industry, the big, bad, evil multinationals and industry, you know, who can't be trusted. And then they took a number of all of the variables that would make a difference to how much needed to be consumed, about bioconversion, about what losses in cooking, about parasite burden and so on. They took all the most disadvantageous features of these things, which hadn't then been measured, multiplied them together and came up with these assessments and a nice publicity photo showing the amount of rice in front of the young lady, I think it's a young lady, would have to eat to make a difference to any health. Now, as it happens, we now know that had we gone with the initial proof of concept rice, it would have made a significant difference to vitamin A contribution to deficiency in developing countries, and maybe then we could have improved it later. But as it was, I think largely because of this activity, the inventors and others were caused to step back and say, oh, yeah, maybe they're right. Maybe we have to work to get the concentration up. About this time, actually in 2002, the UN Convention on Biological Diversity came into effect, or I'm not sure whether it came into effect then, but it came about as a result of a meeting in Rio de Janeiro, the first meeting where the civil society, now called NGOs, were invited to attend. And the principles that they came up with in the convention are very sensible. Human beings are at the center of concerns for sustainable development. They're entitled to a healthy and productive life. And further down, all people should work together, Principle 5. And Principle 4, in order to achieve sustainable development, environmental protection shall constitute an integral part of the development process and cannot be considered in isolation from it. It's part of the thing. Now, a few years later, a subset, an annex to this convention was produced, which is called the Cartagena Protocol. And I'd just like to go to Principle 15, picking up on the mathematician's comment just now about the definition of the precautionary approach. The precautionary approach, precautionary principle is not a defined principle that is defined the same way everywhere. Different institutions use it in different ways, so I have no idea what's written in the French Constitution, but what's important from the perspective of how genetically modified crops are regulated around the world are these conventions, particularly the Cartagena Protocol. So Principle 15 of the CBD said in order to protect the environment, the precautionary approach should be, and this is, 15 of the Convention on Biodiversity, said in order to protect the environment, the precautionary approach should be widely applied by states according to their capabilities. Where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation. Now, that principle, which was 15 of the Convention on Biodiversity, actually jumped up to number 1 objective, the sole objective, the principal objective of the Cartagena Protocol, in accordance with the precautionary approach contained in Principle 15. And note that it refers to the environment. Handling and use of living modified organisms resulting from modern biotechnology, not just transgenesis, not just GMOs, from modern biology that may have adverse effects on the conservation and sustainable use of biological diversity, taking also into account risks to human health. Where's health in Principle 15 of the CBD? And specifically focusing on transboundary movements. Now, focusing on transboundary movements makes it very, very difficult for international research, especially between public sector institutions, to work. When Norman Borlaug, the Nobel Peace Prize winner in 1972, I think, was sending his seeds from Mexico to India and Pakistan, he spoke to people about it and he put his seeds in an envelope and sent it to them. End of story. When we wanted to send, in response to Indian scientists' requests for golden rice seeds from the Philippines to India, it took 2 years. That's quite typical for how long it takes to move things around. Peter's been trying, I hope he doesn't mind me saying so, to move his high-yield rice to Siat in Colombia from Germany for how long? 2 years? For 2 years, it's still sitting in Germany. This is an unreasonable impediment to progress. And looking at this Cartagena Protocol, health and environment, human health and environment, we just heard from Mark Van Montague, there has been no cases anywhere of any problem with human health or environment from GMO crops in the years that have been passing since they were first used. Because of the Cartagena Protocol, the first steps in progressing golden rice into actual rice, and this is rice growing at Erie in the Philippines, and you notice that it's growing in a sort of thing you probably don't recognize. It looks a bit like a glass house, but you can't see through the glass. That's because actually these are screens. They're screens to let the air through, but to prevent insects moving through or birds coming in. And the idea of this is to prevent any contamination of the environment at the first stages of the development process. But they also prevent the proper assessment of how plants grow in the wild, because in this condition, these plants are not exposed to the wind and the rain, which is normal in a growing field. Have I run out of time already? Okay. I forgot to set my timer, so I may have run out of time. Now I've gone too far. Well, let me just say that we did some work to find out whether golden rice works in China, and the results were that golden rice may be as useful as a source of vitamin A as preformed vitamin A from vitamin A capsules or eggs or milks. This is a quote from the paper that was produced. That allows us to say that 40 grams, less than the amount of golden rice in this Petri dish, which I'm holding in my hand and which is being held there, would save life and sight. But nevertheless, Greenpeace made a fuss about that too and caused hysteria, which resulted ultimately in the paper publishing the work. There were no concerns relating to integrity of the study data or accuracy of the research results or the safety of research subjects, but nevertheless, it resulted in the paper being retracted, and the little note on the right says that the US Department of Health and Social Security are currently reviewing whether Tufts University reviewers violated ethical due diligence and process standards in reaching the conclusions that they reached, which accused the people who did this work of ethical violations, and that was the reason that the journal retracted it. The problem of the Cartagena Protocol also prevents taking crops to the field sufficiently early, and so this process also stops the traditional use of seed breeders using their traditional techniques, and they can much more quickly decide whether plants are useful or not than a load of molecular data with no baseline to compare it with. We've had crops destroyed in the field, and incidentally, these are not farmers. You know, they got tattoos, colored hair, video cameras. Greenpeace in the background. This was done attributed to a Philippine group who traditionally have worked with Greenpeace. Greenpeace say they hadn't got anything to do with this, but they certainly supported the activity. And most importantly, it's not the regulations itself, but that Greenpeace have used the suspicion caused by the Cartagena Protocol to instill fear into the public and private organizations, listing all those there, including the UN organizations, including the Pontifical Academy of Science, including governments, including companies, have steered clear of any involvement in crop controversy entanglement by doing, taking other routes towards success with what they're trying to do. And individual scientists have been significantly distracted, which has also slowed down projects involved. So this is my final slide. At the top there, it's science and innovation which have driven yield improvements in this period on the slide from 1890 to 2010. Different technologies being applied, and we've talked with Peter about yields. Now we know, and this is, crop breeding for yields has been going on for 12,000 years. We've now seen that GMO crop technology is particularly useful for improving the micronutrient content of staple foods of the poor, including cassava, sorghum, cooking banana, rice, and others. And traditional seed breeding techniques, to emphasize what Howdy was saying, have not been able to achieve success with increasing iron and zinc, or folate, or provitamin A in rice, for example. But all have been achieved using precision agriculture, using GMO techniques. And the preventable human misery and death is a legacy of Greenpeace's anti-GMO activities, which I believe have cynically used the Cartagena Protocol, in which they were involved in the creation of it, by the way, and have boasted about how they achieved all their objectives in getting it, and that's the result. Thank you.